So this is the predicted paper I have written for the paper that is on the 7th of June. This is paper 2, the calculator paper for Edexcel, based on what we've already seen on paper 1 and just looking at topics that come up lots each year. So hopefully you find it helpful. Let me know in the comments if there's anything you'd like me to go over or any more questions you would like me to do, and let's get into it. So these are all the topics that I've put on the paper. We've got solving linear equations and so on. So if you know for sure that there's a topic here that you're going to struggle with, maybe go away, revise that first and then come back and have a go at the paper, or vice versa, have a go at the question. If you're struggling on it, then you know what the topic is called and you can go away and do some more practice on that. Question number 1, solve 5x minus 6 equals 3 brackets x minus 1. So when we're solving equations, I like to put a dotted line where the equals is, and what we do to one side, we're going to do to the other. So I've got 5x minus 6 on the left-hand side, and on the right-hand side, I want to expand this bracket, and I'm going to write that as 3x minus 3. I'm doing 3 lots of the x and 3 lots of the minus 1. Everything in the bracket has been multiplied by 3. I now want to get rid of my smaller number of x's, so we're going to subtract 3x from both sides, and that leaves me with 2x minus 6 equals minus 3. We're now going to add 6 to both sides, and 2x would equal, now if we're at minus 3 on the number line and we add 6, we're going to come up to positive 3. So if 2 lots of x equals 3, we just want to know what x is, and that means we need to divide both sides by 2. So x equals 1.5 or 3 over 2, however you want to write it, that would be absolutely fine. There we go, question number 1 done, and that was 3 marks. Question number 2, write 84 as the product of its prime factors. So I'm going to do the prime factor tree for this, 84 at the top. And that's going to be 42 times 2, and circle any prime numbers that you get to. So 2 is a prime number, so we circle it, and we carry on with 42. 42 is 6 times 7. You could do 21 and 2. It doesn't matter how you do it, but if you get to a prime number, circle it, and then the 6 isn't prime, so we're going to split that up to be 2 times 3. Both of those numbers are prime, so we circle it. So our answer is 2 times 2 times 3 times 7. Now it hasn't said write it in index form, so we don't have to, but also 2 squared times 3 times 7 is the answer there. Either of those answers would get you full marks, but you must write it as a multiplication. Don't put commas in between, that's a really common mistake that I see. Part B, find the lowest common multiple, the LCM, of 60 and 84. So that's asking you for the first number that's in the 60 times table and in the 84 times table. Now the easiest way to do this, we've already got the prime factorisation for 84 from part A. And so I'm just going to do the prime factorisation for 60. 60 is 6 times 10. Neither of those are prime, so let's carry on. 6 is 2 times 3 and 10 is 2 times 5. We've reached all prime numbers, so we're going to stop there. And then we know that 60 is 2 times 2 times 3 times 5. And again, we could write that as 2 squared times 3 times 5. We're now going to do our Venn diagram. This circle on the left is going to be for 60, and this circle on the right is going to be for 84. And whatever they've got in common can go in the middle. So they've both got a 2. We can put that in the middle. They've both got another 2. So again, that can go in the middle. They've both got a 3. And then we've got a 5 left over on this side and a 7 left over on this side. If I wanted the highest common factor, I would just need to multiply all those numbers in the middle together. So that would be 2 times 2 times 3, which would be 12. But they haven't asked me for the highest common factor, they've asked me for the lowest common multiple. To get the lowest common multiple, we're going to take that 12 and times it by any numbers that are left on the outside. So 12 times 5 times 7. You can type it in your calculator, this is a calculator paper, and that would be 420 for 2 marks. Question number 3. Here is a trapezium drawn on a centimetre grid. On the grid, draw a triangle equal in area to this trapezium. So we need to work out the area of this trapezium and then draw a triangle that has the exact same area. Now the area of a trapezium, we would do A add B divided by 2 times by the height, where A and B are your 2 parallel sides. So this would be A, this would be B, and H is your height going straight up. So here we can see that A is 2. We can also see that B is 7. That's the distance from here to here. We know it's 7 centimetres because it says it's on a centimetre grid. So we've got 2 squares there and 7 squares there. And the height, that needs to be perpendicular, which means going straight up. So that's going to be 4. And now we can just use our formula. We are given this in the front of the paper. So 2 add 7 divided by 2 times by 4. 2 add 7 is 9. So that is 9 divided by 2 times by 4, which is 4.5 times 4, which is 18 centimetres squared. So we've worked out the area of that trapezium. We now just need to draw a triangle that has an area of 18. Now, triangle, base times height divided by 2 needs to equal 18. So that means that the base times the height needs to make 36. Because when we divide it by 2, it will then make 18 and be correct. So I just need two numbers that times together to make 36, and you can pick any two you like. There were lots of different answers here. I'm just going to go for 9 and 4, I think. 9 and 4. So I'm going to draw a triangle that has a base of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And a height of 4. And you could go up anywhere you liked. You could go up to here. That's 4 squares above. And down to here, that's still 9 times 4 divided by 2, or you could make it a right-angled triangle, which most students did on this question, if I remember correctly, and make it look like that. And just checking, this is 9 centimetres, this is 4 centimetres, and we would do 9 times 4, which is 36, and then do 36 divided by 2, which would give us an area of 18 centimetres squared. Lots of answers there though. You could have done one that's 6 wide and 6 tall, lots of different answers. As long as when you do base times height divided by 2, you got 18, that would have been correct. Question number 4. So for this question, a lot of you like to use the table function on your calculator. So if you're happy doing that, then that's great. If you're not happy using that, there's lots of different ways to do this. So I would say either you need to use brackets on your calculator or you need to use the table function. So if you're using the bracket method, I would get you to type exactly what this says here into your calculator, but every time you see an X, I want you to put brackets. So you're going to type into your calculator bracket bracket squared minus 2 bracket bracket add 2. So just typing that in your calculator, and then we're just going to change the number in the brackets to be each of these numbers up here. And that will give you the correct answers. Otherwise, you can use the table function. So on my calculator, I get that by pressing menu and then going across to table and hitting equals. It will then say f of x, and in that you can type what they've given you there. I'm just going to press alpha, and the second bracket, that gets me an x. So x squared minus 2 alpha x add 2. All the calculators will vary slightly, but I will put a video on my TikTok explaining how to do this one, and I might put it on YouTube Shorts as well. And then hit equals. G of x you can ignore, it depends what calculator you've got, it'll ask you different things, but hopefully that makes some sense. We want to start, if it asks you the start, we're starting at minus 2 and hit equals. We want to end at 4 and hit equals, and the step is what it's going up in. So we're going up in 1, so the step is 1, that's correct, hit equals, and then it will give you the table of values. So minus 2 it says 10, minus 1 it says 5, 0 it says 2, 1 it says 1, 2 it says, scroll down to get to that, 2 it says 2, and 4 it says 10, and then we've got all of those values. So that's the way of doing it if you're doing it as the table, but like I said, brackets works absolutely fine. And that's a great way of doing it. So bracket, bracket squared, minus 2, bracket, bracket, add 2. Whatever you would like to do is absolutely fine for that question. Now we're just going to plot each value. So that's a coordinate, that's a coordinate, that's a coordinate, and so on. So let's plot minus 2, 10 is there. Minus 1, 5 is there. 0, 2. 1, 1. 2, 2. 3, 5, and 4, 10. And we were expecting, because it's a quadratic, we were expecting it to come down and go back up, joining all those points with a nice smooth curve. Make sure you draw in pencil just in case it does go wrong, and then you can redo it just like that. Part C then says use your graph to find estimates of the solutions of the equation x squared minus 2x add 2 equals 4. So that's what we just drew. We just drew x squared minus 2x add 2, and they're saying, using the graph, can you tell me when the thing you just drew equals 4. And to find out when it equals 4, we're going to draw a line across at y equals 4. We've changed the y here, and it now is 4. So we want to know what happens when y is 4. What happens, what solutions are there? So we've got a solution here, and we've got a solution here, and if we go down, there would be a range of answers for this, but be as accurate as you can. I'm going to get that that is minus 0.75 from here, and 2.75 from there. So two solutions, minus 0.75 and 2.75 for those. Question number 5, standard form. Write 4.5 times 10 to the power of 5 as an ordinary number. So times 10 to the power of 5 just means we're going to times by 10, 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 5 times. So 4.5, if you times that by 10 once, it becomes 45. The decimal point would then be here. Now it's the numbers that are moving, but it's far easier to bounce the decimal point, so that's why we do that. But it's the numbers that are changing place value here. So 1, 2, 3, 4, 5. Fill in any gaps with zeros, and you'll see that that is 450,000. For the record, times 10 to the power of 6 is million, so if you've got times 10 to the power of 5, we know it's going to be in the hundred thousands. Write 0.007 in standard form. Now for standard form, it has to be a number between 1 and 10, so we're going to use 7 for that, times 10 to the power of. Now if we want to divide by 10, divide by 10, divide by 10, that's going to be a negative power. So I'm going to do 7 times 10 to the power of minus 3, because it would take me 3 jumps to get that 7 into the thousandths column. So 7 times 10 to the minus 3. It's always times 10 for standard form, never divide. But if you want to divide, that power is just going to be negative. Part C, work out 4.2 times 10 to the power of 3, add 5.3 times 10 to the power of 2. Now you can do this and keep them in standard form, but if you're adding or subtracting, my advice would just be get them out of standard form, do it, and put them back in. So 4.2 times 10 to the power of 3, we just need to times that by 10 3 times. So that would be 4,200. Add, and then 5.3 times 10 squared is timesing by 10 again, and that's going to be 530. When we add that together, we get 4,730, and then we can put it back into standard form. Now we know in standard form it needs to be between 1 and 10, so 4.73 times 10 to the power of something, and that's going to be 1, 2, 3, so times 10 to the power of 3, and that would be your answer. Of course, this is a calculator paper, so you can just pop that in your calculator, but I would be really careful. Just put brackets around here just to be really sure that you're going to get the right answer there, just to make sure your calculator knows that that's a number, that's a number. Yeah, just be really careful and try it a couple of times, make sure you get an answer that makes sense. Okay, question number 6. Change 8,000 centimetres cubed to metres cubed. Now we know that normally to go from centimetres to metres, 100 centimetres is 1 metre. So normally we would be dividing by 100. However, this is not just changing length, this is changing volume. So we need to change the length, the width and the height. And that's going to mean dividing by 100 cubed. So to get from centimetres cubed to metres cubed, we're not just dividing by 100. Because we're dealing with volume, we're dividing by 100 cubed. So I'm going to type in my calculator 8,000 divided by 100 cubed, which is dividing by 100, dividing by 100 and dividing by 100. And that gives me 8 times 10 to the power of minus 3, which is 0.008. We're dividing by 100 for the length, dividing by 100 for the width, and dividing by 100 for the depth. Question number 7. The diagram shows a right-angled triangle and a quarter circle. The right-angled triangle ABC has an angle ABC equals 90 degrees. The quarter circle has centre C and radius CB. Work out the area of the quarter circle. Give your answer correct to 3 significant figures. You must show all your working. So we know that for the area of a circle, we need to do pi r squared, pi times the radius squared. And the radius of the circle is this distance here, which we do not know. Or it's also this distance here. This would be the centre of your circle. So it doesn't matter which way we go, we just need to go to the edge of the circle, which could be going to D or could be going to B, it doesn't matter. So the easiest thing to do here is to look at this side because we've got a right-angled triangle with two of the sides that we already know. So we can just use Pythagoras here. To get the shorter side, we're going to subtract. So we're doing 9 squared, take away 6 squared. That is Pythagoras. If you wanted the longer side, you'd be adding, but because we've already got the hypotenuse, the longest side, we're going to do 9 squared, take away 6 squared. So that is 81, take away 36, and that gives me 45. We then need to square root that 45. Now you can square root it, and that will give you a decimal, which you then need to write down lots of figures. I'm going to keep it as root 45, because I then just think that's really nice and accurate for us typing into our calculator in a minute, because we're going to have to go on. Never round any answer until you get to the very end of the question. So now, for the area of this quarter circle, we know if it was a whole circle, we would need to do pi r squared. But we just want a quarter of the circle. So I'm going to do pi times the radius squared, and then I'm going to divide it by 4. If you had a weird number of degrees, not a weird number of degrees, but if you had a random number of degrees, you would need to do pi r squared times however many degrees you had. Let's say it was 38 out of 360, but here it's 90 out of 360, which is a quarter, so dividing by 4 does the exact same thing. But if you feel more comfortable doing it like this, that's absolutely fine as well. So you're timesing by 90 out of 360. Perfect. So pi times, now the radius we now know is root 45. So I can do pi times root 45 squared. But we know that root 45 squared is just 45. So I've got 45 pi, and now I need to divide it by 4. So typing all of that into my calculator, I get, and I'm happy now that I can write it as a decimal, 35.34291735. So I like to write down everything that's on my calculator display and then round it afterwards. So give your answer correct to 3 significant figures. They just wanted the area of that quarter circle. We don't have to add on the triangle or anything like that. 3 significant figures. So 30, that 3 there is your first significant figure, second significant figure, third significant figure, and we want to round there. The next number's a 4, which rounds down. So that is going to be 35.3. And the units are normally on the answer line. Yeah, they are indeed meters squared, 35.3. So well done if you got that. Lara is a skier. She completed a ski race in 1 minute and 54 seconds. The race was 475 metres in length. Lara assumes that her average speed is the same for each race. Using this assumption, work out how long Lara should take to complete a 700 metre race. Give your answer in minutes and seconds. So for this, we need to draw our speed, distance, time triangle. Speed, distance, time. And then we'll cover up the thing we want to know. We've got, for her first race, we've got her distance and we've got the time. The distance is here, the time is here. Now, if we want her speed, ideally, because of the units, we want the speed to be in metres per second. It doesn't really make sense for the units to be in metres per minute. If it was kilometres and hours, then we want the speed to be in kilometres and hours. But here, metres and seconds makes most sense. Now, if you want the speed to be in metres per second, then you want the distance to be in metres and you want the time to be in seconds. Your units always need to match up. So in that case, we need to make sure the distance is in metres, which it is, but the time needs to be in seconds. And at the minute, we've got 1 minute and 54 seconds. So 1 minute 54 seconds is 60 seconds for the minute and 54 seconds extra. So that is 60 add 54, which is 114 seconds. And now if we want to know her speed, we cover up the thing we want to know and do the sum that's left behind, which here would be distance divided by time. So the distance is 475 divided by the time, which is 114 seconds, and that's going to get our speed in metres per second. So that is 475 divided by 114, and that is 4.16 recurring. Now be really careful in your calculator. Just keep that answer in your calculator. The 6 needs to be recurring. If you rounded that to 4.16, or if you left it as 4.16, you'd lose some marks here because it wouldn't be accurate. So the speed is 4.16 recurring, but I would just leave it in your calculator. That's going to be easiest. Now she does a race of 700 metres. and we want to know how long it's going to take her. So now we want the time. If you cover up t, we need to do distance divided by speed, and we're assuming that she's going the same speed. So we now want to do 700 divided by the speed, which is 4.16 recurring. Now, if you just type 4.16, like I said, you're going to get a different answer to the correct one. So I'm going to use my calculator and I'm just going to type 700 divided by, and I'm going to press that answer button. And that's just going to make sure that whatever this answer was here goes here. So it saves me having to type it in. There is a recurring button, but it's a little bit trickier. So that is 168 seconds. And we know it's seconds because we wanted the time, we gave distance in meters, and we gave speed in meters per second. So the units will all match up. So 168 seconds, but they want the answer in minutes and seconds. We know that 60 seconds is a minute. So 120 seconds is 2 minutes. And then we've got an extra 48 seconds. So that's 2 minutes and 48 seconds to make 168 in total. Part B, Lara's average speed actually increases the further she goes. How does this affect your answer to part A? So the first race she did was only 475, and then she went 700. So actually, she's going to get quicker for this race. And if she's quicker for that race, that second race, then her time would actually be less. If she's going faster, the time is going to be less. So the time would be less if she is going faster. There we go. Question number 9. ABC is a right-angled triangle. Work out the length of BC. So this is SOHCAHTOA. So let's do our SOHCAHTOA triangles. And then we'll label our sides. So most important thing to do with SOHCAHTOA. I know this is SOHCAHTOA because we've got a right-angled triangle. We've got angles involved. I want to know the length of BC. This one here, let's put an X down here. But if I had two sides, I could get the third side using Pythagoras, but I only have one side and one angle, so that's going to be a SOHCAHTOA question. Let's start by labeling our sides. So this side over here is opposite the included angle, that interesting angle that they've told us about, and so that is the opposite. If you go over from the right angle to the longest side, that is called your hypotenuse. And then the angle that is next to your included angle, your interesting angle, is called the adjacent. And I think it's easy to spot the adjacent because it's normally between the two angles, but it depends on the question, but normally it's between the two angles. So there we go. What two sides are involved? Well, the opposite is absolutely involved because it's what we're trying to work out. So that's definitely involved in this question. The adjacent, we know that's helpful information, so that would be good to involve that. The hypotenuse, I don't know it and I don't want to know it for this question, so that's probably not going to help me out very much here. So because I've got A and O, I'm looking for the triangle that has the A and the O in it, and that's going to be TOA. Now remember that the O stands for opposite, the A stands for adjacent, S, C and T stand for sine of the angle, so in this case it'd be sine 56, cos 56, or tan 56, matching up with your calculator. But here we're using this triangle, so that T is tan 56. If we want the opposite, we cover up the thing we want to know and do the sum that's left behind, and that's going to be T multiplied by A. So tan 56 multiplied by the adjacent, which is 12. Typing that in your calculator, make sure to shut the bracket after the angle. So tan 56, shut the bracket, times 12, or you can type 12 tan 56 or 12 times tan 56, and that gets me 17.79. We're rounding it to one decimal place, so 17.8 is your answer for that one. We've then got another right angled triangle, but this time we want to work out the angle. We're still using our triangles, SO, CA, and TOA. I could work out the third side here using Pythagoras in this question because I've got two sides and I would want to know the third side, but they've asked me for an angle and that means it's still SOHCAHTOA. So first thing we're going to do is label our sides. We know this is the hypotenuse because it's over from the right angle. We know that this is the adjacent because it's next to that interesting angle and it's also between the two angles again. Like I said, sometimes it is, sometimes it isn't. And this side over here is your opposite because it's opposite that interesting angle. Which two sides are involved? Well, we've got the hypotenuse, that's great, and we've got the adjacent, so that's great as well. I don't know the opposite, and I don't want to know the opposite, so that's not involved. Here we're looking at A and H, so we're going to be using CA. When you want the angle, it's actually this bottom left thing that you're covering. You're either covering sine, cos or tan. And in this case, because we're using K, we're going to be covering up the C. Now we know that cos of the angle, so cos x, is equal to the adjacent over the hypotenuse, which is 15 over 18. But I don't want cos of the angle, I just want to know what the angle is. Now to find out what that angle is, we need to do cos to the minus 1. So we're like uncosing it. That is not very mathematical, but that makes sense to me. Cos to the minus 1, 15 over 18. So to get that cos to the minus 1, we're pressing shift and cos. Fraction button, 15 over 18, or you can write 15 divided by 18, that's absolutely fine. And that is 33.557. It's a sensible answer, isn't it? If you've got something like 839, you think, that doesn't make sense, that can't be an angle. But here, 33.557, I'm happy that that's a sensible answer. I'm going to round it to one decimal place, so 33.6 degrees. Question number 10. Shape A can be transformed to shape B by a reflection in the x-axis, followed by a translation. Find the value of C and the value of D. So shape A can be transformed to shape B by a reflection in the x-axis. So let's start by reflecting it. The x-axis is this one. So if we're reflecting it, it's coming 2 squares down, so we also need to reflect that on the other side. And that means that your triangle is going to go here, like this. 3 squares down and up to that. So you're just reflecting each point in that mirror line. And then a translation. Now a translation is when it's just moved and we're going from this one to this one. You can pick any corner you like, but if you're picking this corner, for example, then you need to go to this corner on the other one. If you were picking this one, you'd need to go to this one and so on. Now a vector, the top number is left or right and the bottom number is up or down. Negative is left, positive is right, negative is down, positive is up. So, sorry, spat on the screen. So I'm counting from here, 1, 2, 3, 4, 5, 6 to the left and down 1. So that is going to be -6, -1, because we're going left, which is negative, and we're going down, which is negative, -6, -1, so C is -6, and D is -1. And that would be it. Shape A has been reflected, and then translated, and then we get B, and that's the answer. Question number 11. Liquid A has a density of 1.8 grams per centimetre cubed, and liquid B has a density of 1.2 grams per centimetre cubed. 80 centimetres cubed of liquid A is mixed with 40 centimetres cubed of liquid B to make 120 centimetres cubed of liquid C. Work out the density of liquid C. So I like to lay this question out in quite a specific way. I would have liquid A like this, add liquid B like this, equals liquid C like this. And for each, I'm going to write density, mass, volume. Now we were having a conversation in the live on TikTok how to remember that triangle, and someone said don't move Vera. I don't know who Vera is, but it's quite memorable, so don't move Vera. Density, mass, volume for each of those liquids. Now just like speed, distance, time, you can add masses together, you can add volumes together, but you can't add densities together. For speed, distance, time, you can add distances together, you can add times together, but you can't add speeds together. So we need to make sure that we're not adding any densities together here. So liquid A has a density of 1.8. Let's pop that there. Liquid B has a density of 1.2. And we're adding 80 centimetres cubed, that's a volume, of liquid A, with 40 centimetres cubed of liquid B to make 120 centimetres cubed of liquid C. Now I don't have any masses, but we can work out masses. We know that if we want the mass, we'll cover that up and do the sum that's left behind, which is density times by volume. So for the mass here, I'm going to do 1.8 times 80. And that is 144 grams. For liquid B, again, we're going to do 1.2 times 40, which is going to be 48 grams. And then we can add those masses together. I know if the mass of liquid A is 144 and the mass of liquid B is 48, then in total that has a mass of 192 grams when we add it together. And now we can easily work out our density because we have the mass and the volume in total for liquid C. And we know that density, if I cover up density, I need to do mass divided by volume. So that's 192 divided by 120, which is 1.6. The units are there, grams per centimetres cubed, because we did grams divided by centimetres cubed. There we go. 1.6 is your final answer for that one. Question number 12. Here are some graphs. In the table below, match each equation with the letter of its graph. So let's just go through these. This is an exponential graph, something like 2 to the power of x, or 3 to the power of x, or 4 to the power of x, where that power is x. For B, I've got a reciprocal graph, but this is a negative reciprocal graph. Reciprocal graphs can look either these two or these two. If it is in the quadrants that we've got here, that's going to be minus 2 over x, or minus 3 over x, or minus 4 over x, or something like that. The number's not really important, but that x is on the bottom of the fraction, something like that. For C and D, we've got trigonometric graphs, in that one of them is going to be sine and one of them is going to be cos by the looks of it. So sine is an S and cos is a cup. That's how I remember them. They go up to 1, down to minus 1, normally. And they go along to 360. So sine starts from 0 and cos starts from 1, from 0. So we've got sine here and cos here. And then for E, we've got a quadratic, so we're expecting this to be something like x squared, but if it was just x squared, it'd be going through the origin. So let's say x squared minus 5, or something that's going to make that y-intercept down in the negative. For F, we've got a cubic. Now, that's when it wiggles like this, but it's not very wiggly. Normally, this is something like x cubed. It's not going to have add 5 or anything like that, minus 5 like we did for this one, because that would move the y-intercept up or down, and it's going through the origin. We can see that. It might have something like, I don't know, 5x or something like that, but it's not going to have a constant term, a number on its own. This one's a negative quadratic, so something like minus x squared. This one, again, is another reciprocal graph, so a bit like this one, but this time it's positive. It's in this quadrant and this quadrant, so it's going to be something like y equals, I don't know, 2 over x, or 3 over x, or 4 over x. Last but not least, we have an exponential graph, but this is negative. So this is the reverse of this one, where we've got y equals 2 to the power of minus x, or something like that. So it's coming down. Now, looking at what they've given us, we can now have a look and think which one makes most sense. So sine, we said that that was graph C. For the second one, we're looking for a cubic. And we can see that that was only possible for F. F is the only cubic that we were given there. And again, like I said, it didn't have an extra number, so because we knew it was going through the origin, so that makes sense for that. 2 to the power of x is going to be A. That is our exponential graph, but positive, going up and up and up and up and up. And we've got a reciprocal graph, last but not least, and that is H. Wasn't a negative reciprocal, just normal reciprocal, so there we go. Those are the answers. Question number 13. Louise invests X pound in better investments for 3 years, and Sadiq invests X pound in County Bank for 3 years. At the end of the 3 years, the value of Louise's investment is £344,605. Work out the value of Sadiq's investment at the end of the 3 years. So with Louise, we know that she's put X pounds in the bank, and then she's getting 2.5% per annum. So that's extra money on top of her investment. So her investment is 100%. And we're adding an extra 2.5%. So in total, she gets 102.5% each year of the value that she's already on. Now, we're going to use our calculator for this. And if you want 102.5%, the easiest thing to do is to times by 1.025, because we want that percentage, 102.5%, as a decimal. And to convert from percentage to decimal, we divide by 100. So that's 1.025. And we raise that to the power of the number of years. So if we want that for 3 years, we're going to times it by 1.025 to the power of 3. And we know that after that sum has taken place, she gets £344,605 as her answer. So therefore, to find out how much money she invested in the first place, we're just going to work backwards, and we're going to divide by 1.025 cubed. So in my calculator, I am typing 344,605 divided by 1.025 cubed. And that is 320,000. So we now know that she invested 320,000. But because Sadiq also invested X, we also know that Sadiq invested 320,000 because it's both X. So it has to be the same value. So I'm going to do 320,000 for Sadiq times by, now his is a little bit more complicated. He's getting 2% for the first 2 years. So that is 102% because the 2% is extra on top of his investment. And we're going to do that as a decimal. So 1.02. But we get that rate for 2 years. So that needs to be squared. The power is the number of years. And then we need to times it by whatever he's going to get for the third year. Now, we know it's 3 years because that's what they're asking us in the question. So for that third year, we want him to get 103.5%. And that, as a decimal, is 1.035. So that's going to be the sum. You can do it in 2 parts if you want to, but I think it's easier to just do it all as one. So 320,000 times 1.02 squared times 1.035. And that gets us 344,580.48. And that's money, so I'm happy that it's 2 decimal places. If it was longer, I would round it to 2 decimal places because it's money. And that's it. Answer on the answer line, 344,580 and 48 pence. Question number 14. The group frequency table gives information about the times in minutes that 80 office workers take to get to work. Complete the cumulative frequency table. So for the cumulative frequency table, we know that we need to add it up as it goes along. Look at the categories. Instead of being 0 to 20, 20 to 40, 40 to 60, we're now going 0 to 20, so that's the same, that's still going to be 5 people. But then we're going 0 to 40. So I want to know how many people were in the 0 to 20 category and the 20 to 40 category. So I need these people, I need the first 5 and the next 30. So that's going to be 35. And then we're going from 0 to 60. So that's all the people that we've got so far, the 35 people, and another 20 people. So adding on 20 gets me to 55. Then we're going to add on 15, which gets me to 70. Then we're going to add on 8, which is 78. And then we're going to add on 2, which is 80. Normally they'll say in the question how many people there are in total, and you want to make sure that that matches up with the number you get down to at the bottom, just to make sure that you're correct. And we plot this on a graph, and we're going to plot at the top of the category. So always for cumulative frequency, you're plotting at the top, and it should make a nice smooth S-curve or something that looks a little bit like that. Let me just change what this looks like. So now we're going to plot these values on the graph. We're plotting at the top of the category, so we're going across to 20 and up to 5. This is a little bit small, but just to fit it all on one screen. Across to 40 and up to 35. Across to 60 and up to 55. Across to 80 and up to 70. Across to 100 and up to 78, and across to 120 and up to 80. And now we're just going to join them all up with a nice smooth curve. Don't judge me if this is a little bit off. I'm doing my best. There we go. So that's our cumulative frequency graph complete. It then says use your graph to find an estimate for the percentage of these office workers who take more than 90 minutes to get to work. So for more than 90 minutes, we're going to 90 on the graph down here. We're going to go up and then go across where we hit our cumulative frequency graph. And be really, really careful here. Because this is 10, each square must be 2. So that's going to be 74 there. So how many people were over 90 minutes? Took more than 90 minutes, just going to be the people above. So if that reads at 74, there must be 6 people above to get up to 80. So it's 6 people, but it asked us that as a percentage of all of the people. So that's going to be 6 out of 80. And then because we want it as a percentage, we're going to times it by 100. So 6 out of 80 is 0.075, but then times it by 100 to get it as a percentage, and that is 7.5%. Question number 15. Here is a triangle ABC. Work out the length of AB. Give your answer correct to 1 decimal place. Okay, so this question is giving me sine or cosine vibes. How do we know if it's sine and how do we know if it's cosine? With cosine, you are looking for two sides and the angle in between. So if I knew, for example, that this was 10, that this was 15, and I had an angle of 63 degrees or something like that, and I wanted this side over here, that would be the perfect setup for the cosine rule. So two sides and the angle in between, ideal for the cosine rule. For the sine rule, you need to have a pair. So that's if you know this angle and this side, because pairs are opposite each other, or if you knew this angle and this side, for example, again, opposite each other. So looking at this question, do we have any pairs? I've got this angle, but I don't know this side, so that's not a pair, that's no good. I've got this side, but I don't have this angle, that's no good. And I've got this angle, but I don't know this side, so that's no good. However, I can very, very easily get a pair because of the information they've given me. We know that angles in a triangle add up to 180, so I can very easily get this angle by making sure the angles add to 180. So 34 add 26 is 60 degrees, which means that we're left with 120 degrees for this angle here because we know that angles in a triangle add up to 180. And now I've got a pair. So this is going to be the sine rule. We want the length of this side here. So with sine rule, you want to use the pair that you've got. So this is one pair. Let's colour them in that colour. And we're going to then use this angle with this side. The 26 degrees over here is kind of irrelevant now because we don't have a complete pair over there and it's not the pair that we're interested in. So we want a side, so sides go on top. If you want an angle, you put the angles on top. So sine rule is going to be A over sine A equals B over sine B, and you are given that in the front of your exam. And then just filling in the value. It doesn't matter which one you call A and which one you call B. Ignore the labels, they're normally not very helpful. So I'm just going to call the blue ones A and the yellow ones B. So let's say 23.8 over sine 120 equals X, that's our missing side in yellow, over sine 34. Now, if you want to know what X is, at the minute it's being divided by sine 34, so we want to get rid of that by multiplying both sides of the equation by sine 34. So, in my calculator, I am typing 23.8 divided by sine 120 times by sine 34. 23.8 over sine 120 times by sine 34. And that is 15.36766. They want it to one decimal place, so that is going to be 15.4. Well done if you got that. Question number 16. Using algebra, prove that 0.136 recurring times 0.2 recurring is equal in value to 1 over 33. So for this, I'm going to say let x equal 0.1363636. That's what that means, that number there. And if x is that, I'm going to go to 100x. Now, some of you might choose to go 10x and 1000x. This is just the way that I choose to do it. Because there are two numbers repeating, I like to times by 100. So 100x is 13.6363636. I'm timesing by 100 because I want the 3's underneath the 3's and the 6's underneath the 6's. That would also happen if you did 10x and 1000x, but I find this way quicker, but each to their own, it doesn't matter. I'm now going to do 100x, take away 1x. So I'm doing the bottom row, take away the top row, and that is 99x. Everything after this 3 would cancel. 3 take 3, 6 take 3, 3 take 3, and that's why we've lined them up, so that that would happen. And now I'm doing 13.6, take away 0.1, which is 13.5. Dividing both sides by 99, I've got x equals 13.5 over 99, which is 135 over 990. I've times the top by 10 and the bottom by 10 to get rid of that decimal point. And now I'm just going to see if that simplifies. Because we are blessed to have a calculator, you can just type it in and your calculator will simplify it for you. So 135 over 990 does indeed simplify to 3 over 22. Great. So we're going to leave that there, and now we're going to worry about the 0.2 recurring. So this time I'm going to use y, just because. 0.22222, and here, because there's only one digit that's repeating, I only need to times by 10 to line it up. 2.22222. Taking away, we're going to do the bottom row, take away the top row. So that is 9y equals 2. Everything else would cancel. So y, if we're dividing this side by 9, also dividing this side by 9, is 2 over 9. And now we need to show that when you times those two values together, you get 1 over 33. So I'm going to write 3 over 22 times 2 over 9. And you can do it. 3 times 2 is 6. 22 times 9 is 198. There is some cross-cancelling possible there, but I'm just going to do it this way. And then again, my calculator will cancel that down for me. I'm going to trust and hope that that comes down to the answer that they've given me. We love a show that question, and it does indeed. So I'm just going to write equals 1 over 33. Checked it in my calculator that it did simplify to that. And there we go, 3 marks. Question number 17, and we've got a histogram. The histogram gives information about the distances 80 competitors jumped in a long jump competition. We've got the frequency density up the side. So really important with histograms that we notice up the side, we don't have frequency, we have something called frequency density. The frequency is actually given by the area of each bar on a histogram. So to get the area of each bar, they're all rectangles, you would just do base times height. It says calculate an estimate for the mean distance. Okay, let's start by finding out how many people are in each category. So in this first category, this first bar here, to find out how many people are in that, we just need to work out the area. And the area is going to be base times height. From 6.4 to 7.2, that is 0.8 wide. So we are doing the base, 0.8, times the height, which is 10. 0.8 times by 10 is 8. There are 8 people in that category. For the next category, we've got 0.4 along the bottom, and the height is 50. 0.4 times by 50 is 20 people. So 0.4 times 50, that's 20 people. For the next category, again, I've got 0.4 for the width, and the height, base times height for a rectangle, 0.4 times by 100, and that is 40 people. And last but not least, I've got a width of 0.2 and a height of 60. So I'm going to do 0.2 times by 60, and that is going to be 12. So now I know how many people are in each category. We need to think about doing the mean. Now, normally when we do the mean from grouped data, we have a lovely little table, and it will look something like this, where it will go 6.4 to 7.2, 7.2 to 7.6. You'd have more like this. I'm not doing it very properly here, but hopefully you get the gist. 7.6 to 8, and then 8 to 8.2. And then on this side, we'd have the frequency, and we've got the frequency now. So that's 8, 20, 40, and 12. To find out the mean, we use the midpoint of each category, times across, add it all up, and divide by how many people there are. So for this first category, I need the midpoint of 6.4 and 7.2, and that is 6.8. So we're going to do 6.8 times 8. We're going to do 7.4 times 20, that's the midpoint, 7.4 is the middle of that category. We're going to do 7.8 times 40, and we're going to do 8.1 times 12. There we go, so those are the answers to those calculations. We then need to add all of that together, which is 611.6. And that would be the total. If they asked me the total distances that they all jumped all together, then that would be that. But it says that they want the mean, and the mean is going to be given by dividing by how many people there are, which we could get by adding up all of the values that we've got, or we know it's 80 from the question, so we can just say divided by 80. You could add up the total of each bar, but that's going to be quicker. 611.6 divided by 80 is 7.645. I'm not going to round it. That would be my answer for that. Does it make sense? Is it a sensible answer? Yeah, I'm going to say it is. The majority of people jumped up here between 7.2 and 8, and most of them in that category 7.6 to 8. So yeah, I'm happy that that is a sensible average for that question. Question number 18, and we're expanding 3 brackets here. When you are expanding 3 brackets, you want to multiply 2 of the brackets together get that answer and then times it by the third bracket. So I'm doing 3x add 2 multiplied by 2x add 1. 3x times 2x, that is 6x squared. 3x times 1 is 3x. 2 times 2x, that's 4x. And 2 times 1 is 2. So altogether, remember to simplify before you carry on multiplying. That's going to be 6x squared, add 7x, add 2. And we now want to multiply that by x minus 5. So I'm going to do 6x squared times x and 6x squared times minus 5. Then I'm going to do 7x times x and 7x times minus 5. And I'm going to do 2 times x and 2 times minus 5. Some people like to do this one in a table. It's entirely up to you. I just like to times it out, but give it a go, see what you prefer. 6x squared times x is 6x cubed. 6x squared times minus 5 is minus 30x squared. Now we're going to move over to the 7x. So 7x times x is 7x squared. And 7x times minus 5 is minus 35x. Then moving over to the 2. 2 times x is 2x. And 2 times minus 5 is minus 10. Collecting up some like terms, so I've got minus 30x squared and 7x squared. And I've also got minus 35x plus 2x. The 6x cubed and the minus 10 would need to stay on their own. So I've got 6x cubed. If I'm at minus 30 and I add 7, that's minus 23x squared. If I'm at minus 35 and I add 2, that's minus 33x. And then minus 10. That's your final answer. Question number 19. D equals an eighth c cubed, where c is 10.9 correct to 3 significant figures. So that is a clue that that number has been rounded. By considering bounds, work out the value of d to a suitable degree of accuracy. So they're not saying give us the upper bound or give us the lower bound. They're saying by considering bounds. And that means you need to do the absolute biggest and the absolute smallest that it could be, and then compare them and see what a sensible answer would be. So let's do the upper over here, and let's do the lower over here. Now it's been rounded to 3 significant figures. The first significant figure is in the tens column, the second significant figure is in the ones column, and the third significant figure is in the tenths column. So this has actually been rounded to the nearest tenth or the nearest 0.1. Whenever we have bounds, we halve what it's been rounded to. So if it's been rounded to the nearest 0.1, we're going to halve that and go 0.05 above and 0.05 below. So my upper and lower bound for C are 10.95 and 10.85. Now to get D, it is 1/8 multiplied by C cubed. Sometimes when the letter is on the bottom of the fraction, we need to think about whether we need to use the lower value to make it bigger and the upper value to make it smaller. But here it's just very straightforward. We are just cubing C. So the bigger C is the bigger it's going to go, and the smaller C is the smaller it's going to go. So for the upper bound, we're going to do 1/8 times 10.95 cubed. And for the lower bound, it's going to be 1/8 times 10.85 cubed. Typing both of those in my calculator, these are my 2 answers, and now we need to decide what a suitable degree of accuracy is. Now for this, we're always going to use significant figures. So if I rounded them both to 1 significant figure, they would both round to 200. If I rounded them both to 2 significant figures, this first one would round to 160, and the second one would also round to 160. If I round them to 3 significant figures, this one rounds to 164, and this one rounds to 160. So we can see that at that point they become different numbers. What you are looking for is the most accurate you can make it, but they still are the same. So in this case, our answer is going to be 160, because both bounds agree to 2 significant figures. That would be my answer. How many marks is that? 4 marks for that one. Very nice. Question number 20. solve this equation. So when you see algebraic fractions, if there's anything that can be factorised, we're going to do that. So I can see that 3x minus 6, we can factorise that. So 3 lots of x minus 2 over x add 5 divided by x minus 2 over 2x add 1 equals x minus 7 over 2. Now when we divide fractions, we keep, change, flip. And I'm going to put that in a bracket because you can see that that's going to cancel in a second. And then you can think of it, once it's timesing, you can view this as a single numerator and this as a single denominator. So if there's something in common, when they're timesing, you can cancel even if they're not in the same fraction, because timesing, the order doesn't matter. So I've got x minus 2, so I'm going to divide by x minus 2 here and divide by x minus 2 here. So I'm left with 3 lots of, I've still got the 3 here, 3 lots of 2x add 1 on the top of the fraction over x add 5 equals x minus 7 over 2. And now we want to make this into an equation, and to do that I want to get rid of the denominators. If I times both sides by 2, I'll get rid of this, but I'll need to multiply this side by 2 as well. And so you can actually multiply up, this 2 can go up here, and this x add 5 can go up here. And that only happens when the equals is in the middle, but it's quite a nice trick. So I'm going to do 2 lots of this, which makes it 6 lots of 2x add 1, equals, and then on this side I've got x minus 7 and I'm multiplying it by x add 5. That is 12x add 6 equals, and then on this side I'm going to expand this out, x squared add 5x minus 7x minus 35. Now this is looking like a quadratic, so I'm going to make it equal 0. So this side is going to become 0 equals x squared. We need to take 12x away from both sides. I've got minus 2x already from this. So if I'm taking away 12 more, I'm at minus 14x. And then I'm going to subtract 6 from both sides. So that is minus 41. Minus 35 minus 6 is minus 41. It said give your solutions to 3 significant figures, which is giving me quadratic formula vibes. It's probably not going to factorise if it says give your solutions to 3 significant figures, so we're going to use the quadratic formula, which you get given. It's minus b plus or minus the square root of b squared minus 4ac all over 2a. So a is 1, that's the number in front of x squared. B is minus 14, it's the number in front of x, and C is the constant term, the number on its own. So putting those values in, if I've got minus 14 plus or minus the square root of minus 14 squared, but let's not do minus 14 squared, let's just do 14 squared because we know that it's going to be positive anyway. Minus, you can put it in a bracket if you want, but don't put it in not in a bracket or it will mess up. 4 times 1 times minus 41 all over 2a, which is going to be 2 times 1. Popping that in my calculator, I'm going to use the plus the first time I put it in my calculator, and I'm going to use the minus the second time I put it in my calculator, and that's going to give me the 2 different solutions. So, use that fraction button. You can put 14 in instead of putting minus 14, that's absolutely fine as well. 14 plus the square root of 14 squared, minus 4 times 1 times minus 41 all over 2a, or 2 times 1, and that is going to be 16.4868 for the first solution, and then just use your left arrow and go back to where you put that plus in here and change it to be the minus, delete, minus, and then SD to get that as a decimal, minus 2.48683. So we're going to write our answers to 3 significant figures as they said. So that's going to be 16.5 and minus 2.49. There we go. 3 significant figures for each. And that was 4 marks. Question number 21. The diagram represents a solid cone. The cone has a base diameter of 20 and a slant height of 25. A circle is drawn around the surface of the cone at a slant height of 10 centimetres above the base. The curved surface of the cone above the circle is painted grey. Work out the area of the curved surface of the cone that is not painted grey. Give your answer as a multiple of pi. You must show all your working. So we're given here that the formula for the curved surface area of a cone is pi RL. And I know that it's 25 all the way down here. So therefore this part here must be 15. Now this is actually a similar shapes question. So we know that if we just take the top section of a cone, that's just a smaller version of the cone. They are similar shapes. So therefore I want to work out the scale factor here so I can work out the diameter of our smaller cone. So to do that, I'm going to take the scale factor to be 25 divided by 15. That's the same length on each cone, or the corresponding length on each cone. So that's going to get me my scale factor. So 25 divided by 15, and I honestly would just leave this as 5/3. That's going to be 1.6 recurring, but I don't really want to work with recurring decimals. It's likely to go wrong. So I'm going to say the scale factor, the linear scale factor, is 5/3. Now, to work out the area, we're going to need to do pi times the radius times the length. And so I need the radius. The radius of this bottom one, from the middle to the edge, would be 10 because the diameter is 20. And the radius of the top one, well, let's go from 20 to this, or you could go straight from 10 to be honest. If I do 20 and I divide it by 5/3, that's going to get me to the length of the smaller cone because I'm using that linear scale factor. So 20 divided by 5/3 is 12. So it's 12 centimetres all the way across, which means the radius is 6. That then means that the curved surface area, let's just pop that over here, linear scale factor is 5/3. We need to now do the curved surface area of the whole cone, subtract the curved surface area of the small cone, because what we're interested in is the curved surface area of the white bit, the bit that's left. So let's get the curved surface area of the whole thing first, and that's going to be pi times the radius, which is 10, times by L, which is our slanting height, so that's 25. And we're going to subtract the curved surface area of the smaller cone, which is pi, times the radius of the small cone, which is 6, times the slanting height, which is 15. So I'm going to do 250 pi minus 90 pi, and that is 160 pi. It said, give your answer as a multiple of pi, you must show all your working, and that is it. That is the area of the curved surface of the cone that is not painted grey. 4 marks, perfect. And last but not least, here are the first 5 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. So I'm going to write them out again, 10, 21, 38, 61 and 90. What is the difference? So we've gone up in 11 here. Then we've gone up by 17. Then we've gone up by 23. Then we've gone up by 29. Now, if that first number is not the same, we need to do the second difference. So that's going to be plus 6, and plus 6. And that number should be the same. If it isn't, check your maths, probably done something wrong. So just go back and check that. Whatever that second difference is, I want you to divide it by 2. And that tells you how many n squared we require for the nth term. So 6 divided by 2 is 3. If it was 4, we'd put 2n squared. If it was 8, we'd put 4n squared. We're just going to half that number. So this is 3n squared. Now normal n squared, the sequence n squared, goes 1, 4, 9, 16, 25. It's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. But I don't want n squared, I want 3 lots of n squared. So I need to take this sequence and make it 3 times bigger. So that would be 3 instead of the 1, 12 instead of the 4, 27 instead of the 9, 48 and 75. I'm just timesing each of those values by 3. How much more do we need to get to our sequence? Well, I'm on 3 and I want 10, so that's 7 more. I'm on 12 and I want 21, so that's 9 more. I'm on 27 and I want 38, that's 11 more. I'm on 48 and I want 61, that's 13 more. And 75 to 90 is 15 more. What is the nth term of this sequence? this is the 2 times table, so 2n, but the 2 times table starts on a 2, this starts on a 7, so it's the 2 times table, add an extra 5. And together, those two sequences, this one and this one, when you add them, you get the sequence that we wanted. Therefore, our answer is 3n squared, add 2n, add 5. And that's the end of the paper, 80 marks. I hope you found it helpful. Let me know in the comments if there's anything you want me to go over again or if you're not sure about anything. And I will see you. I will be live on TikTok and YouTube from 7 till 9 the night before the exam, 7 till 8 for foundation and 8 till 9 for higher. I hope you've enjoyed it. Thank you so much and I will see you soon.